Hello everyone. Today we're going to learn how we apply a cloud masking to a satellite data. In this case, we'll use Landsat satellite data. I'll be using the Google Earth Engine cloud computing platform to do that. So we're going to turn this cloudy image to a cloud-free image by applying a cloud masking algorithm. So as you can see, this is a pretty cloud contaminated image. So if you have a remote sensing project or any analysis that deals with the satellite data, removing clouds is a very important task in order to have pretty consistent and high quality analysis result based on your satellite image. So the first thing you need to do before you do any analysis on a satellite image is converting or masking clouds and then generating a cloud-free image. So I'm going to show you a little bit advanced algorithm to do that on the Earth Engine platform using JavaScript API. Let's get started. So the first thing we do is we import our study area, and then we write a cloud mask function. We also write a scaling factor. Most satellite data comes as integer to save storage space. So when you use the satellite data in your project, you need to do mostly apply scale factor to convert the data into a floating point data type. And then we'll be using, we'll filter the data by our subset area as well as timestamp, and then we'll generate a median composite, and finally we'll visualize our result. So let's get started. So the first thing is I'll load countries database as always, and so I'll import my geometry, or just I would say ROI. So before that, in our JavaScript, you need to declare a variable by starting with var and then is equal to. So I'll import from the Earth Engine data catalog a dataset, a shapefile dataset for all countries, and I'll subset that. So if you type in LSIB simple 27 on Earth Engine, you find this dataset. So I'll apply a filter to this data. Filter EE filter equal, and then it has a country name attribute, which is country NA. If you print the properties, you'll find that. But in this case, I'm not gonna do that. So you can write any country you want. In this case, I'll be using Uganda. And that should be it. And I need to close my statement. So actually I have to write this over here. Just for, all right. So the next thing is to write actually our cloud masking function, which is, so in JavaScript, to start a function, you just write function, and then you write the name of the function. It's better to write something similar to what the function does so that you can remember. So you can say cloud mask function, and then you have two things. First you have a bracket which stores the input parameter. For that, I'll just call it image. And then you need a curly bracket to store your parameters, okay? I'll create a variable to write the cloud mask formula, which is, I'll store that as keyway mask, and I'll call this image here. And then I'll select the keyway peaks, the keyway band in the Landsat image. You can find that in the property, so pixel. So this will give you the keyway or quality assurance information. So based on bitwise, and so I'll provide that specific keyway information to remove cloud. So what I'll do is parse int, and then because the cloud bits are stored in integer, so I'll write this. I'll actually have to type in as a text. So, and then equal to 0. All right. And then another one is I'll have the saturation mask. So I'll create a variable image, select radar sats equal. All right. It should give me a pretty cloud-free image. So now I'll replace the original bands with the cloud mask variable. So I'll have to apply update mask. So return is the image, the final result that you want, right? Return image, which is my image here. So these are the two cloud masking parameters that I'll be using. So I need to update mask. Update mask. Okay, that was a typo there. So I'll do the QA mask here. And then I'll update also the second parameter here. All right, so that's about our cloud mask function. And another information which might be useful is, so bit 0 is a fill. Let's say, so cloud masks are stored in bit. So this is a fill. This is based on the Landsat data. So bit 1 is dilated cloud. So you can use any of these parameters for your cloud masking. Bit 3 is cirrus. So if you want to mask bit cirrus cloud, you can use bit 3. Sorry, bit 2. Bit 3 is normal clouds. Cloud, and last one, bit 4, cloud shadow. So depending on what you want to mask, you can use any of these parameters in your keyway mask algorithm here. All right, so next is to actually write the scale factor. As I mentioned earlier, most satellite data comes as integer, but they provide you with the scale factor to convert from integer to a floating point. So we're going to apply that scale factor here. So I'll write another function here. So I'll name it apply scale factors. And then as always, I'll have my input parameter here. Just I'll say image. And then you have your curly bracket to store your parameters in the function. So there are two groups of bands for the Landsat 8 data, the optical bands and the thermal bands. So I'll do the scale factor algorithm for both of these optical and thermal bands. So I'll create the optical parameter here, optical bands. So I'll apply the scale factor for the optical bands, and then so my input here is the image, right, which I defined the input parameter for my function. And then I'll select the optical bands. They are stored as SRB. And so I'll get the scale factors from the Earth Engine product description in the image collection. You can go to Landsat 8 and you can find this data. If you want to multiply. So I already just copied this scale factor value, which is provided with the image collection on Earth Engine for the Landsat 8. And the offset parameter that is given for that product is 0.2 minus 0.2. So I've done now for the optical. Let me do for the thermal bands. So thermal bands, okay, and then instead of SR here for surface surfactants, I'll do ST thermal bands, and so multiply. So mind you, the scale factor is different for the thermal and the optical bands. So. And then for the thermal bands, the offset value is 149.0. And the last thing is I have my input parameters. The last thing is just a return value, which is applying these arguments. So what I want to return is that image I initially defined, but add these bands. So I'll apply the add bands function, Earth Engine built-in function, and then call this variables, the optical bands rescaled, and also I'll do the same for add bands for the thermal bands. Okay, and then I'll apply the same here. All right, so that should be it to write my scale factor function. So I've done here two things, right? So we have written the cloud masking function, and we also have written the scale factor function. So the cloud masking function will remove clouds, all right? We'll generate a cloud free image. And the apply scale factor function will convert the satellite product from integer to a floating point. So the next step is actually to import the Landsat 8 collection to data. You can go to the Earth Engine data catalog and find the Landsat 8 collection if you want to. But I've already copied that. So first we're gonna do, what we're gonna do is we're gonna import the collection. We're gonna generate the first one. The first image collection would be a raw image collection, and the second image collection would be a cloud masked image collection, which will apply our cloud mask function here. And then we compare the two, the cloud free image and the cloud contaminated image. So let's first import the raw image collection here. So raw image. So the raw image is, I'll copy my image collection from the Earth Engine data catalog here, and then put it here, and then write filter. I'll do because Landsat data is it's a global planetary scale geographically, and also temporally. It's a long time series, so I need to subset it by a steady region to spatially subset it, and also I'll need to filter by time to filter it temporally to just focus only on timestamp that I need for my analysis. So in this case, I'll filter data only for 2022. So let's apply filter. So let's filter date. So we'll be using an Earth Engine object, which is filter date. Filter date. So the filter date will accept a date timestamp, a start date, and an end date. So I'll provide the start date and 01, 01. And I'll also do the same for the end date. This is just the timestamp that I need the satellite data to import from the entire image collection. I'll subset only this timestamp. So when I run my analysis, I'll only do analysis for this specific dates, right? So 2023, 01, 01. That means this is just 1 year data for entire 2022. Okay, so the next filter is filter bounds to subset it spatially. It's a spatial filter. I'll use again bounds, filter bounds, filter bounds. So filter dates will filter the dates. Filter bounds will filter by a subset parameter, where in this case we provided ROI here. So we're gonna copy our study area. We have already created a subset region, right? So now we have subsetted our data by timestamp and time spatial or geographic coverage. And next, let's apply the scale factor because the satellite product comes as integer. So let's apply our scale factor here, which is this function. So mind you, we have already written the function, but we have not executed that to our image collection, so nothing is happening. So let's copy that and then map. So what map does on Earth Engine is it applies a function. It goes through the image collection and apply that function for to each image in that image collection. So what when we do map that function, it will apply this function to every image in the image collection. All right. Actually, we need to do a semicolon at the end of our statement. That's why we're seeing that. Okay, so we have now the raw image, and the second one is actually the same thing, but we'll apply a cloud free. Instead of writing this again, I'll just use this and modify it, copy that and modify it. So instead of the raw, I'll say cloud free because we are using a cloud free. We're applying our cloud mask algorithm this time, right? So we're gonna apply this function, cloud mask function. So we'll be using the same timestamp, the same geometry. We'll apply also the same scale factor, which we did. We'll do something else here. So what's different from this one, the first one, is we'll apply our cloud mask algorithm, which is this one. So something like this, we applied the scale factor. We'll just do map and then apply our cloud mask. So what this does is it will just apply that cloud mask algorithm. So this one is a cloud-free image collection, and this is the raw image collection without the cloud mask algorithm being implemented or applied. Okay. So, because this is an image collection, we're gonna create just one single image so that we can visualize. So we do that by applying a median composite. So we can use create a variable for the cloud masked image. So we will use the cloud masked version. So we're gonna use this image collection, which is cloud free, right? And then apply median, that's the reducer, which applies aggregation. So it will look at all images and then generate for a specific location, long information. It will take the median value for that pixel location from all the images within that image collection. So you'll have at the end one single image, which is a median composite. All right. Okay, so let's do the same for the cloud contaminated or a cloudy image, I would say. So this is our cloud image. Instead of the cloud free image collection, I'll use the raw image, which is cloud contaminated, right? So we have now a cloud free image, and we also have a cloud contaminated image. All right, excellent. So the last thing is to actually visualize our cloudy image versus our cloud contaminated image. Okay, so let's create a visualization parameter. We can say RGB vs. Okay, this stores just the bands and the range, the minimum maximum value, kind of to optimize our visualization here. So I'll open a curly bracket to store this parameter. So usually the minimum is 0, and then the max is 0.3. So that's the min max, and then the bands that I want to use in this this visualization is, I'll use the SRB4, and then I'll use another band, which is band 3. SRB2, right? And then map, I'll just say map center object. So the map center object, usually just to adjust the zoom level, right? Because Earth Engine like the map canvas down here has a global view, so you want to zoom into your study site, right? So let's just map this cloud masked image, cloud free image, and the raw cloud contaminated image. Okay. So I'll use map add layer in Earth Engine. So I'll use the cloud masked version, the cloud free image first here, and then I'll apply, actually I'll clip it by my study region, right? That way I can see a more smaller image, and also I'll provide this visualization parameter. Okay, and then just let's give it a name, cloud free. That way we remember this is the image that cloud masking has been applied. Let's also do the same thing for the cloud contaminated image, which is cloudy image here, right? Let's just copy that and then apply the same clipping to subset it and the same visualization parameter. Instead of cloud free, this one is cloudy image, right? All right, that's about it. So what we have done so far is we just imported our ROI, region of interest, wrote a cloud mask function. We applied a scale factor to convert from integer to floating point. We imported the raw image collection. We didn't apply cloud masking. We imported the raw image, but also applied a cloud mask function here, and generated a composite aggregate image to generate one single image from the image collection. And lastly, we're gonna visualize these two images, the raw image and the cloud masked image. Let's see what's gonna happen here on the map canvas once we execute that data, right? All right, so we got our cloud-free image. Excellent. So this is our image. Let's zoom out a little bit. So the first image was, the image without applying any cloud masking. So you can see pretty, cloud contaminated over here, over here, over here. So you can zoom in and see how much cloud contamination there is. You can see the cloud cover white in the image. This is just a raw image without applying a cloud mask algorithm. So let's just see the other one, which is cloud free. Look at that. That's a significant difference. So if you were to perform your analysis remote sensing project without doing or applying a cloud masking, so you can imagine how erroneous your analysis result or interpretation for any project, related application, or even scientific publication. So it's really important to apply a cloud masking algorithm, or just do a cloud masking, be it a simple cloud mask or a complicated one such as this one. It's advised that you do cloud masking operation to your satellite image, in this case a Landsat satellite. So overall we have in this video we've done a simple example using a Landsat image to convert this cloud contaminated image to a cloud free image.